All right, here we go. Thank you everybody for joining. This is Alex. Welcome to this webinar. We are going to talk about how to design for failure and speed with FeatureOps. If you don't know FeatureOps, if you have never used Unleash before, that's totally cool. We'll look at a lot of different things, and we'll also do a quick demo. So let's jump straight in. This is the agenda for today. We're going to talk about designing for failure. We're going to look at different frameworks and techniques to reduce the blast radius, and we'll talk about what that means. We'll describe and analyze a little bit what is FeatureOps, and we will do a live demo. Now, about the demo, I wanted to participate in that. So let me run another poll here. I want to ask you, which AI coding assistants are you using most frequently or most often, or in your day-to-day if you're a developer or whatever you're doing with that coding assistant? Be careful with what you pick, because whatever you pick, whatever is picked the most will be used in the actual demo later. So this is a fun social experiment. I kind of guessed what people will lean into, and I will share the results publicly so you guys can verify how the voting went. Hey everybody, if you just joined or if you're watching this in a few weeks in the recording, we are doing a live poll to decide which AI coding assistance is going to be used for the demo later. And we kind of have a clear winner already, but I'll give it another 10 seconds for people to decide. I see many of you have not voted yet. It's completely anonymous. Don't worry, there is no names coming up, just some statistics. But yeah, we have a clear winner already. I don't know if it's worth waiting. Let's give it one more second. Oh, things are changing. All right, I'll share the results. All right, closing. You should see the statistics. I don't know where, but long story short, the winner was Claude Code, and so we're going to run the demo with Claude later. So stick with us. The demo is the last thing, but it will be interesting, I promise. So let's get started. So why designing for failure? I like starting with why in general. And if you are familiar with things like site reliability engineering or chaos engineering, this is not a new concept. In a few words, things fail, especially software fails all the time. And I'm not the first one to say, this gentleman, for sure, Werner Vogels. At scale, even the things that happen, 0.0000001% of the time will happen every day, even multiple times a day. So this is a fascinating concept in general. And, if you're operating at huge scale like Amazon or Google, this is fascinating. But how does this actually apply to AI agents and AI coding assistants? So let's look into that. I think there are a couple of things that make this super relevant in this phase of where software development is going, because today you can generate literally thousands of lines of code in minutes. And most of the time that code is fine, it looks great, and the AI agent looks really confident. It's providing a lot of succeeding tests and everything looks awesome. But even as the models get better and better, literally every day or every week, we need to keep in mind these things are a stochastic model. There is some probability involved, and sometimes their output is great, sometimes it's less great, and most importantly, it's not deterministic. So even if you adopt something like spec-driven development, even if you have a great specification, there might be ambiguities in there, and that leaves space for hallucinations or even a blind spot during your human reviews and so on. So today, if you take these things together, a lot of code being generated, the confident LLMs telling you this is perfect, and the iteration and the speed you can do all of this. The big change is that the correctness that used to be familiar for a developer becomes a bit more probabilistic. And the result of that is that failure is to be expected in production. Not only in production, as we'll see later, but this is not the exception anymore. This is kind of becoming the norm. We see things, they fail all the time, but if the AI wrote the code, they tend to fail a bit more often. That's what the statistics say. So if you look back even just a few years, what was normal was to, have a goal about correctness. The code should be correct all the time. Now, many well-respected people are going into the direction of YOLO mode, where they even stop reviewing the code that they generate every day. And if you're like me and you still review all the code and test the code that you generate, there is still a growing knowledge gap as you delegate more and more of that coding. So the goal is shifting from pure correctness to something that I like to call reversibility. Like, how do you ensure system resiliency in this new, slightly different and faster and probabilistic world? So instead of correctness, it seems like the new goal is containment and reversibility. So this is a complicated way to say, in other words, we now know pretty well how to write code and deploy it really quickly, really fast, and really cheaply. The new problem that needs to be solved is how to expose that code to final users in a safe way. So let me take a step back, because there are many things you can do about this at different stages and different layers of the stack as well. So what I wanted to do is introducing some form of a mental framework for you to think about how to reduce the blast radius of all the new code that you're pushing into production every day along all the different phases. So we can start from the top, from model safety and execution isolation in your local development environment, all the way to protecting your repo, protecting your branches and the pull requests during CI/CD and during the rest of the development lifecycle. But then all the way to controlling runtime exposure in layer 4 in your production environment. So in a way, we go from local to production, through different stages. But at the same time, we go from protecting your machine, the top layers, to protecting the users in production in the last layer. So this is pretty, I would say all the layers are pretty important in this framework. And of course, the more you can do and shift to the top layers, kind of shifting left, the better. But it's also important to protect, whatever happens after you deploy. So today I would like to focus on layer 2 and layer 4. I believe this is where you can have the most impact as far as blast radius is concerned, especially in case of prompt injection attacks, hallucinations, and actual issues in production, as we'll see. Now, let's dive into layer 2. This is where you have the big buzzword, sandboxing. There are a lot of sandboxing techniques out there, and there is varying support for the different IDEs and the different CLI tools and the different AI agents out there. So I'll try to map and explain what the techniques are. So let's take a look at the 3 main techniques. I like to call them, kernel level sandboxing, container-based sandboxing, and the last one is a bit of a tricky one. It's remote execution. So let's start one by one. So kernel level sandboxing is something that is provided directly by the operating system. This is available on Mac, on Linux. It's possible to run it on Windows through some magic. Now, the unfortunate fact here is for the many macOS users like me, is that the macOS primitive is considered a legacy, let's say, while the Linux primitive Landlog v3 is a lot more modern and secure in a way. So not surprisingly, using kernel level sandboxing at the operating system level is the most lightweight way in these 3 techniques we're going to look at. So you don't need anything else besides the operating system, as you can imagine. On the other hand, it's not widely used. Maybe you have seen this if you are a Cursor user. You can enable an auto run in sandbox option, which is off by default in Cursor. So it's pretty easy to enable. It's super lightweight. You can run most of your AI agent stuff in this operating system level protection that Cursor enables. One important thing to know is that if you are also using automatic model selection, this is not compatible. So there is no way to do automatic model selection and operating system kernel isolation together. So you need to pick a model. Don't ask me why. So little cons is not a lot of AI agents still support this yet. Now, second technique I want to share with you is container-based isolation. This is probably more familiar to a lot of you who are, probably not surprised to see Docker on the list. But there are also some other interesting open source alternatives and some IDE-specific solutions like the dev containers for VS Code and Cursor. So containers provide a pretty good isolation boundary, I would say, and they still allow you to run locally. So it's pretty familiar developer tools that you'll probably be using for the last 10 years. But they are a bit heavier and slower compared to OS kernel sandboxing. It's also possible to mess it up if you don't configure the volume mounting correctly. As you can imagine, it's a container after all. So there are ways to get out of it depending on how you configure this. So this is possible to configure for Claude and Gemini and Kiro if you are on the AWS world, and Codex, OpenAI, Copilot, and blah, blah, blah. Probably, I would say the most familiar, if you are a Docker user, would be investing a bit on using Docker sandboxes. It's still very experimental, and it's evolving as we speak. For example, last month, it only supported Claude and Gemini. Now it supports also Codex, Copilot, Kiro, and a couple more. This is pretty useful. It comes with pre-built containerized images that you can use to run your favorite AI agents into. Another notable mention, if you are a Docker desktop user, is they also have this MCP toolkit and catalog with over 300 ready-to-use MCP servers already containerized. So it's a pretty interesting solution if you are already using Docker desktop and want a little bit of help already managed for you. Now, the third technique I wanted to cover in this, level 2, how to do sandboxing locally, is actually not doing it locally at all. So this is not a real sandboxing technique in the strict sense, but it still allows you to run the model somewhere that is secured, managed, some kind of managed host, usually by the AI provider itself. Basically, if you do that, whatever prompt injection cannot really sniff your local credentials or your local whatever you're doing in bitcoins or blockchain these days, or it cannot mess your laptop by deleting folders or escaping the containment. So whatever is happening in a remote execution environment, and that solves a lot of the problems with local sandboxing because there is no sandboxing on your machine. The good news is a lot, if not all, the AI agent platforms today already support this, either with a doc website like, Claude on the web or Gemini on the web, or via a mobile application as well. So you can do some of this stuff on the go. I've been using this quite a lot. It's pretty powerful, especially, where you are on the go. Maybe you don't have access to your laptop, or maybe you just need to fire off, a quick self-contained experiment to run in a GitHub repo and generate some code for you to review later today or tomorrow. Now, these execution environments are ephemeral, meaning, even if compromised, even if messed up, you can easily replace them. And there is proper credential management usually, and you have the ability to control if the agent has network access or not. Allow listing specific domains. So it's pretty powerful as far as the controls that it gives you as a developer. Although it's not a silver bullet, it doesn't solve all the problems because if you give it, and you often have to give it GitHub permissions, it will still be able to commit and push and open pull requests and possibly mess with your repository on GitHub or your CI/CD pipelines and whatnot. So it's pretty powerful. It solves a lot of problems that you would have to solve with local execution, and you can kind of do a bit more of YOLO mode because it's not running on your machine, it's running somewhere else where the AI or the cloud provider already has put guardrails around it. So I think you don't have to pick one option. I think these three options are pretty solid. If you're like me and want to dive a lot deeper into the technical foundations of all these sandboxing techniques like containers and micro VMs and gvisor, WebAssembly, there are some more exotic options that we didn't really cover. I strongly recommend this article. It is super detailed. It gives you a lot of behind the scenes how it works on the operating system level. There is also a lot of SaaS options that kind of allow you to do exactly that for the remote execution kind of things. Now, we looked into layer 2. This is where you can reduce the blast radius for things that run on your laptop or in a remote environment. Now I want to go all the way to layer 4. So assuming that the code was written, it was tested, it was reviewed, it was deployed either by a human or by an agent. Now, how can you reduce the blast radius of that code in production? This is the next big question that we can answer in layer 4. And in my opinion, it's not only one question. I like to frame this as 4 different questions. When we talk about runtime control or runtime exposure, the goal is to protect the final users. And so if you ask yourself, who can see the changes, when and how fast the changes are allowed, what exactly runs, so who's enabled for whom, and then what if something breaks? We'll look at these 4 big questions to protect the users in production. So let's start with one. Let's start with who can see your new functionality or whatever new piece of code that you have written. So these techniques allow you to, achieve targeted exposure basically by defining segment or cohort of users. For example, it could be your internal users and then a small group of beta testers, before you roll it out to, 25%, 50%, and then 100% of your customers. Now, the mechanism here could be based on the role of the user, on the geography, on the device, or the platform they're using, or the app version they are using, or even some custom attributes, like an email or something specific about your app. And again, here the goal really is to contain risk by affecting a small percentage of the total audience. You could think of this as kind of a feature-specific version of canary deployments, right? Where you expose to a little canary and see what happens there before rolling out everything. Now, the second set of techniques I like to look at is the when, and also how fast do you expose features, or how does it happen? So these techniques are about deciding when the exposure starts and how it progresses over time as well. So it could be time-based, it could involve some automatic progression logic, such as move to the next group after 24 or 48 hours, for example. Now, here the goal is to control the rate of exposure with specific and reusable milestones, ideally. So you don't want to reinvent the wheel every single time you're pushing out new code, or you don't want to, ideally you want to centrally define your process and roll it out the same way every time and handle exceptions as you go. The third set of techniques is about what exactly is running in production. This is probably the most impactful here, because these techniques are about actually controlling the runtime behavior with a runtime feature flag, or with an A/B testing variant, or some kind of conditional logic. Even shadow mode behaviors are interesting, where you enable something, but you don't actually expose it to final user. It's just running in the backend to make sure you can verify it's working correctly, like in the shadows before it's actually visible. Now here, the goal really is to decouple the technical act of deploying code, which you want to do as often as possible, ideally, from the business act of releasing the functionality or the actual execution path in your code, being exposed to the final user. This way, you can enable a functionality in a dynamic way without redeploying the code. I think this is one of the fundamental techniques of this layer 4 approach. And last but not least, we have this idea of what if something breaks, but also the concept that we like to call safeguards. So these techniques are really about implementing a breaking the glass mechanism, such as kill switches, instant rollbacks, even circuit breakers. in my opinion, a lot of bonus points if you can also do something like automatically pause or even roll back or disable a feature based on real production metrics, like could be error rates or performance measurements and so on. So here the goal is to optimize the system for fast recovery, or as we called it before, for reversibility. So the runtime control system should ideally be able to protect your users based on either manual or automatic inputs or signals. So the end goal, all the techniques in this layer 4 are about building reversibility into your system's design. And you probably realize at this point that one of the core components to implement reversibility are feature flags. They're definitely a key enabler from a technical point of view, but we believe that they are not enough. Like, you also need something more. You need culture, you need processes, you need best practices, and a lot more as well. And this brings me to one of the core ideas of this presentation, which is FeatureOps. So you can think of FeatureOps as DevOps on steroids in a way, with a focus on release management. So FeatureOps is not a single tool or a single service, but rather a set of best practices or practices that help you manage feature flags and make releases safer and, most importantly, reversible. So in other words, you can define FeatureOps as the discipline of controlling software behavior at runtime. And I think this is pretty cool. It's so cool that, in my opinion, it gives you superpowers. It unlocks some super interesting things you can do from a technical point of view. So for example, as we mentioned a couple of times, it lets you decouple this idea of deploying code, which you want to do as often as possible in the ideal world, from the act of releasing a feature, which is a business decision or a product management decision. Second, it lets you adopt techniques like trunk-based development to make sure, for example, that you don't get stuck in merging hell while working on your feature branches for 2 or 3 sprints, which even with the best intention is a real problem that medium to large teams tend to face in the long run. And most importantly, if you're building with AI agents, it lets you build at AI speed. What does it mean? It means deploying tens of times per day. It means keeping control of what is actually released and only releasing when the business is ready, without sacrificing speed. Let me pause for a second there and see if there is anything as a question. Not yet. All right. Quick reminder, we are 25 minutes in, so feel free to ask any question. We'll do some Q&A at the end, but also happy to jump on any urgent question you might have right now, so don't be shy. All right, let's keep going. Now, these superpowers are not just fun powers. I think they are real game changers when it comes to things like stability and reliability. In fact, if you look at the last couple of major postmortems, for example, from Google and from Cloudflare last year in, I think it was June and November, you probably remember, like, when half the internet goes down, it's hard to forget. And the interesting things, if you look at the postmortems, is that both of them included feature flags, and this idea of including reversibility as one of the main remediations going forward. So they wanted to add more feature flags or more kill switches to their practices. So not a big surprise here, but if you are working on feature flags every day like we do, that's a good indicator of how such a best practice using feature flags in production is. So the end result of all of these feature ops and reversibility and designing for failure and runtime control is this dashboards for humans, but not only. For now, for humans, for you to handle runtime control and to have visibility and to have traceability and to have change management and to have all the best practices that you need in the enterprise to succeed and to be compliant. Now, this is probably a good time to spend a couple of words about Unleash. If you've never heard about Unleash, quick recap, long story short, the product has been around for about 10 years. It's loved by hundreds of thousands of developers. It's an open source project. It's made in Europe, in Norway. Kudos to the founding team from Oslo. It's also very much a privacy first and enterprise ready project, meaning you can use it in the cloud or you can self-host it in your infrastructure. So it's very flexible and very focused on privacy and integrating with existing tooling. So you don't have to, buy and replace your existing stack, but you can integrate it with your existing technology decisions. So pretty cool project, pretty cool company in my opinion, and it's used and trusted in production by thousands of companies. You probably recognize some of the logos here. There's a small sample of the many companies and products you probably use every day. I know Samsung and 1Password and Docker, Lenovo, Allianz, Vodafone. You probably Visa. You probably use many of these products on a daily basis, and you are already interacting with feature flags, even if you don't know about it. Now, the mission here is simple, and it's something I deeply care about. It's about making your life easy as a developer, and so helping you succeed in the long term. Now, we've talked about the design principles. We talked about a mental framework. We have talked about what are some of the techniques for sandboxing, but then we focused a lot on the layer 4, which is runtime control. But you might ask yourself, how do I go and implement all of these techniques that we talk about? How do you do this in practice? Do we have to learn about all that? How long does it take? Now, the good news is that a good amount, I wouldn't risk telling you a percentage, but it's probably in the high end percentage of the best practices that you need. And even the code that you need to implement, the code itself, a lot of that can be automated these days. And so as you can probably guess, there is an MCP server that we released that solves some of these challenges and that allow you to get up to speed really, really quickly. So when you think about MCP servers, there is a lot of noise out there these days. So everybody built an MCP server in the last year or so. Personally, I like to give structure to this kind of chaos that happened last year. For example, I like thinking in terms of different categories of MCP servers. So let me do the magic and do some categorization here. Like on the top left, you have all the issue and project management kind of things. And then you have the CI/CD and observability kind of things on the bottom left. You have the databases and the data platform in the top right, and the cloud and hosting providers on the bottom right. At the center here, I put all the developer tools, all those MCP servers that help me write better code locally, or maybe automating part of the process, or maybe even debugging with me directly in the browser. For example, the Chrome debugger is pretty cool. Now, this is also where I would position the Unleash MCP server. It helps you write better code. It helps you automate best practices. And so let me tell you a bit more about Unleash MCP server. Like the rest of Unleash, it is open source. And my favorite fun fact is that only about half of the tool that it exposes are API wrappers. The other half of the tools is probably the most important part, is all the tools that give you the best practices, the examples, all the battle-tested lessons that will help your AI coding assistant adapt to your code base, for example, with language and framework-specific guidance that adapt to your code. Now, in my opinion, this is a lot more valuable than just providing an API wrapper. This is the reason why we built it this way. So in a way, instead of fully delegating the thinking part to the AI agent, our Unleash MCP server kind of helps the AI agent reason about what are the FeatureOps best practices to apply in all the different major workflows, like evaluating if a change is worth protecting with a feature flag, or detecting if existing flags already exist, or creating a new one, and then finally wrapping and even cleaning up existing feature flags from your code base. So these are all supported use cases and core workflows that your AI agent will be able to use by leveraging the Unleash MCP server. And you can, of course, learn more on the documentation and on GitHub. Now, we are half an hour in, and it's time for a quick demo. So let me get on in. Who won the poll at the beginning? It was Claude. So let's go for that. Now, the demo itself is on GitHub. So if you want to check out the repository, it's a demo that's using Java and Angular specifically, but it's fine. Today we're only running the front end for simplicity. And it's connected to an Unleash instance using these demo Java Angular project where I have a bunch of different feature flags. Currently, they are all disabled. Now, let me go and pick my editor because we're using Claude, so we don't need the other IDEs. Now, first of all, let me start a project. Let me run and start. So we'll run this locally for a second. Let me go into the browser, localhost. So here's the project. Let me clean up some local storage just in case. All right, so this is the project, and this project is pretty simple. It's a demo use case by use case. So every page of this demo is basically a different use case. I'm showcasing how to enable a UI only component with a flag. I'm showcasing how to use a kill switch, how to enable front-end back-end coordination, and even pricing experiments and A/B tests. But we're not going to look into that. What we want to do here is using the MCP server to add a new functionality live to this demo. And we want to automatically wrap everything in a feature flag, and we want to, play with it in real time. So let me go and launch Claude. There we go. It's the usual, interface many of you are probably used to. And I do see there are some questions coming in, so that's great. Keep them coming, guys. Now, I don't want to bore you with feature, prompt engineering. So I have a prompt file, if it's still there, yes. So here's my prompt. We want to implement a new a new demo use case in the Angular application, which is in the front-end folder. We want to call it Unleash Webinar. We give some hints at how to proceed. A lot of these details that I've added explicitly in the prompt could be part of, a a markdown file, or could be part of, some skill or some, project-specific configuration. I decided to put everything into the prompt just to make this a bit easier for you to follow as well. So let me copy this. Let me paste this in here. So what's going to happen is that it's going to use the Unleash MCP server to basically decide what to do here. Is this a critical enough functionality that deserves a feature flag? All right. So it went straight into detecting if there is any existing flag. And I've specifically not allowed listed the MCP server because I want you guys to see, exactly step by step. So I'm going to say, yes, let's proceed here. It is currently trying to discover existing feature flags in the code base just to prevent duplicates and mess up. This is a good way to start, I would say. I already told it this is an important feature in the prompt, but if I wasn't clear enough, it would probably also run the MCP server tool that allows you to understand whether this is worth or not. So it is now going straight into creating a new flag. It's going to call it Unleash Webinar. It's going to set up some description automatically with some details. And so let's enable this as well. You could easily allow list all the tools, but I wanted to see what's going on. Otherwise, you don't understand much. So now it's going to create a new flag. It's going to give me some details about what happened, and we can go back into the Unleash dashboard to see if it was actually created. Let's give it another second to process and to call some APIs. All good so far. It is created. So now it's actually already implementing. Let me go into the Unleash project. And here we go. There is already an Unleash webinar. New feature flag that didn't exist before. That's good. And let me go back. It's now implemented a bunch of, it's implemented a new webinar component. This is an Angular component for this new page. I like that. So let's create this file. Again, I want to go step by step with you guys. I know this is, it's a bit boring to confirm every single step, but it's useful during a demo, trust me. Now it's adding the route to the Angular routing. Pretty simple. It's added a new /webinar page with this webinar component. So let's confirm that. And it should be almost done at this point. I do see a fun question. What theme are you using for your terminal? That's a good question. I think it's the default. It's the default Mac OS, and I have the dark theme on Claude itself. So nothing custom, guys. It just looks good. So the last change here is updating the navigation component to show the new page. If the feature flag is enabled, it's going to show the new page. Okay, looks good to me. Let's move on. All right, we should be almost there. And I'll go back to the browser in a second. It's now updating the navigation component again to keep track of the flag status and to update a little signal in the component itself. Let's go. If you don't know Angular, don't worry too much. We're just adding a link and adding a page. I know this is a bit over-engineered, but that's the way it is these days. We should be almost there. A couple of minutes of thinking very deeply, but we should be there. All right, everything looks clean. Here's a summary of what we did. We did flag detection. We created a new Unleash webinar flag. We created a new component and updated routing and navigation. So in my other tab, everything is still running without problems. Let me go back to the browser and see. All right, as you can imagine, there is nothing different, because when you implement a new feature flag, you push it to production 10 times a day with your updates, nothing should show up differently until you enable the flag, right? So what I'm gonna do here is I'm going to go to my Unleash dashboard and I'm going to enable this feature flag in the development environment. Now, the Unleash SDK automatically pulls the latest configuration, so there should be a little new link coming up here in seconds. There we go. So we have a new Unleash webinar. This only shows up if the feature flag is on only for the people for which that feature flag is on. Right now, I've enabled it for everybody because it's just me on my laptop. But you can go and configure all sort of constraints and filters and context-based targeting and so on. So if I click here, welcome. This is February 24, and you have some memes and some fun stuff. This is the designing for failure and speed with FeatureOps webinar. All good. What else can I show you? I have also a little trick here in my sleeves. I have a little tool that I call Unleash toolbar. So this allows you to override the value of the feature flag. So for example, I can force it to be off only for me, only on this page, or force it to be on and so on. So it's easy to experiment and test as a front-end developer as well. So there we go. We use Claude to create a new functionality in a project, to put it behind a feature flag, and to conditionally enable it for specific users. There's a lot more to learn, but as far as enabling an AI coding agent to encode all the FeatureOps best practices, all the language and framework specific best practices that we have encoded in the MCP server, this is a good start. so you don't have to invest weeks and weeks on learning new styles, new rules, new best practices, new implementation details for every specific framework. You just jump in and basically inject all these best practices with a couple of prompts, as you are already used to do if you're using these AI agents. So let me go back to the presentation. I know there are a few questions pending that I am definitely going to read in a second, but let me wrap up the presentation so we can focus on the Q&A. If you have a question, feel free to drop it in the chat now. Now, here are my takeaways from today's webinar. Remember the 4 layers that we talked about for blast radius reduction, going from local all the way to production. Runtime exposure or runtime control is the most effective way to protect your final user in production. So if you want to do that without slowing down AI adoption, FeatureOps is the way to go. The main superpower you unlock is this idea of decoupling deployments from releases, and that's super powerful. Feature flags are a tool in your toolbox, and kill switches are a tool in your toolbox that enable this new approach, especially if you're going, AI speed with AI coding assistance. Bonus point, we didn't talk much about this, but with exactly the same primitives and tools and MCP server and everything else, you can also implement A/B tests and full stack experimentation. So this is pretty powerful. And there you go. That's all I had. We are 45 minutes in. I hope it was useful and that you learned something new in this session. Let me now switch to the questions and take a look. We answered what theme are you using? I know that was a game changer, guys. Happy you joined the webinar. The other question I see here is, how can I start small with FeatureOps without over-engineering? I think we just show how to do it. Honestly, the idea is start small, start from something that you're adding to your website or to your project, whether it's backend or front end or mobile. I think the easiest low-hanging fruit there is, do you have something you've always wanted to experiment, or a new variation, or a new something that you want to add to the UI that doesn't really mess with everything else? Like I added a link in the navbar at the top. I didn't completely change the website. So that's a useful low-hanging fruit. And what you can do there is add a feature flag. You can create it with the MCP server. You can create it manually or via API on the Unleash dashboard. And then it's off by default, and try to enable it only for yourself and see how that works. Try to only enable it for your team based on their email in the context that you can provide to the SDK. And then try to enable it for, 10% of the users and see what happens. I think it's a good way to start. There is a lot more depth in here. We didn't go super deep into the enterprise features, the auditability, the change management side of things, the sophisticated targeting rules that you can configure. Good news is a lot of those things you can also do with the MCP server. So if you're unsure, you can say, hey, enable this for 20% of the users, and it kind of does it. So you can really get started simple with the MCP server. I hope that addresses your, how can I get started quickly and small, and then grow without over-engineering. There's another question here. Let me read because it's a long one. All right, so let me read the first half because there is a lot to unpack. So the question is about, okay, I love, feature flags are great. The issue that this person is seeing with feature flags is that they tend to shift bugs right instead of left, meaning to production. I don't necessarily agree with that specifically, but I see the sentiment. The approach is to be able to do runtime control. So what you're affecting with a feature flag is already in production, and I can imagine that can feel scary, but it doesn't mean you're shifting right. You're actually able to do runtime control in production without redeploying, which takes seconds instead of minutes or hours. So it's pretty powerful. But let us continue with the question. They tend to be, they say, not as tightly controlled. I can imagine there is not much automation out there, but we are working hard on that. Something I didn't mention much is that Unleashed does support automated progression, for example. So you can set up automation to say, hey, only release to internal users or to beta customers, but if nothing bad happens in the next 24 hours, roll out to 10% automatically. And you can also say, if anything bad happens, stop everything and pause there and don't go to the next milestone of the release plan. So you can do some sort of automation, but we're not at the question yet, so I'll keep reading. So things get more complicated when the team size grows. I can imagine that's true depending on your culture. So I want to get to the question. Sorry, let me keep reading. Right. So I see the sentiment. It feels like this person, which I respect because they're coming from a very technical point of view here, they feel like the orchestration and coordination needed to justify feature flags could possibly slow down feature release cycle, the time to actually releasing. I can see where that sentiment is coming from. What I've seen recently is that this set of techniques really align well with the idea of governance. And if you are a 10 people startup, I understand, and I've been in a startup many times in my life, governance in a startup doesn't always make a lot of sense depending on what you're doing and who you're selling to. And so adding too much bureaucracy or complexity to releasing a functionality may not make sense. But what the data shows in real large production systems and enterprise companies is that if you do have governance, if you do have the right types of governance and internal practices and cultural policies, what happens with governance is you can actually go faster compared to the companies that do not have the governance. So I think feature flag also help in that matter. I agree with you, like everything, if you do it wrong, it will not make you faster or more compliant or anything. But I think one of the best points we made in this webinar is that with the MCP server, you can embed a lot of these best practices directly, not only in the code, but also in the way you orchestrate and clean up and manage the, what happens after the release kind of scenario. So there is a lot to unpack there. And again, I see the sentiment. I have my own thoughts, and we work with very large companies on a daily basis that are actually showing exactly the opposite of what your sentiment is. So let's also talk one-to-one if you want. I think this is a reasonable conversation to have. Thank you for asking. Let me see if there's any other question here. Okay, but there is one. So once your feature is shipped and works fine, do you clean flags in your code? When and how? It might be difficult to keep 10 years of flags coexisting in the code. That is also a reasonable observation. So what typically happens, or what we recommend doing at least, is to clean up often and quickly after the release, because the reality is that 90% of feature flags are temporary and they should exist in the lifespan of the release cycle. It could be a week or 2 or 3. It shouldn't be 3 to 6 months. It shouldn't, definitely shouldn't be 1 or 10 years. So there are some exceptions, like the 10% is, things like operational flags or kill switches or permission-based flags. Those things that become part of the product or part of the feature itself. Like if you have a kill switch, as long as the feature exists, you need the kill switch to turn it off. So in that case, the cleanup doesn't happen until you actually remove the feature. But this is an edge case. For the largest majority of feature flags, you do want to clean them up quickly, after the release is done, whether, you decide to keep it on for everybody or whether you decide to keep it off, depending on the outcome. Maybe it's an experiment, maybe not. The idea is that you do want to remove that from your code. And that's also something that the Unleash MCP server can help you do. You can just say, hey, go and clean up these couple of feature flags or this specific feature flag, and it will go and identify wherever it's used and what patterns you have been using and how to disable the the corresponding side of the if statement, if that makes sense. So as you said, it might be difficult to keep all those feature flags in your code. The trick here is that you shouldn't keep 10 years of feature flags in your code. And it's a good practice to go and clean up early and often after your release cycle is wrapped up for that specific feature. And we're happy to help you. And actually, the Unleash dashboard itself comes with a pretty useful, health dashboard that shows you all the different stages and all the different, where is this specific feature in its release kind of life cycle. Like, is it in development? Is it already in production? Is it ready to be cleaned up? So you have this little report that also help you understand, project by project, where are you and what should be do to make sure you clean up. So thank you for asking. Let me see, any other question? Thank you guys for staying until the end. If you voted for Claude, I hope it was a good decision. Of course, the MCP server works with any MCP compatible AI agent or coding assistant. I had Copilot and Cursor in the list of options, but you can definitely use other options like JetBrains or Kiro or whatnot. So feel free to experiment with the MCP server. And one last detail, we are currently allowing you to use the MCP server as a local MCP server with standard IO transport. We are working hard to make sure you can also use a remote version. So if that's something that is a blocker for you, let us know. We would like to know. There is a Slack channel that you can use to talk to us. You can find it on the getunleashed.io website. So I don't see any more questions, and that's all I had for you guys today. If you want to dive deeper into Unleash, if you want to try, there's a free trial, and you can get a demo from our technical team. So feel free to reach out, and I'm also happy to introduce you and help you out on the Slack channel. So thank you for coming to the webinar. Let's connect on LinkedIn if you're not connected already. And yeah, have a great rest of your day. See you soon.